Hi and welcome. Usually this would be a monthly update video where I talk about my LED projects and what progress I made this past month. However, with 2021 now behind us, I also started thinking more about my learnings of this past year and how to continue now in this coming year. So let's do things a bit differently and talk about my top learnings of 2021 and how they impact 2022, shall we? Starting with need a complex machine, then buy it assembled. While building electronics together yourself can be a really fun learning experience, this can also easily change once we are talking about a lot more complex machines with a lot of moving parts and a lot of possible points of failure, where tightening a screw a little bit too much here and having another screw a little bit too loose there can easily cause problems that are very difficult to figure out as a total beginner. And can cause you a lot of headache. That's something I learned at the beginning of the year when I got my first 3D printer, a Prusa Mini, as a DIY kit. To be fair, Prusa is known for building really high quality and reliable FDM 3D printers. 3D printers that melt plastic, that is. And I absolutely believe that they are reliable, at least as long as you buy them fully assembled, or you build them up together with someone who really knows about building 3D printers. But for total beginners who want to have as little problems as possible, I recommend getting a fully assembled 3D printer. So you don't have issues like me, where I had problems with the nozzle being blocked, the gears not moving properly, the filament not sticking to the build plate, and a lot of other things. Or if you want the most reliable 3D printer that is still decently affordable and also has the best printing quality, and you have an extra space for having this 3D printer and with some very good airflow and ideally also access to a window, then I highly recommend you check out SLA printers. In other words, resin 3D printers. That's also what I ended up doing by getting an Anycubic Photon Mono X. And well, this one also caused me a bit of a headache, but in a different area. Just when it comes to reliability, this printer was like way better than the Prusa Mini I had before. Basically, I had like dozens of prints over the last few months, and once I figured out how to properly print them, I didn't had a single print failure in multiple months, like at least half a year, which was quite a bit different with the Prusa Mini. But it also makes sense considering that SLA printers are just mechanically speaking way simpler than any FDM printer. Instead of having 3 axes that move individually, there's only one that moves up and down. And instead of having a nozzle that can easily be blocked and where you have filament that can easily break, you just have a bath of fluid resin that gets hardened by UV light. So the question of if your print will be successful isn't a question anymore of luck, but a question of have you selected the correct printing settings and have you added the support correctly. And once you figure that out once, you can just repeat it over and over and over and over again. However, this doesn't mean that SLA printers are perfect, which brings me to my next learning of 2021. Saving money sometimes can cost you a lot more. I think honestly SLA printers have basically just 3 downsides. First, the resin is toxic, so you need to wear gloves to prevent having it on your skin. Second, you have to clean the 3D print and cure it afterwards for exactly the same reason, so you don't get in contact with this uncured resin. But third, that was the only one that I struggled with quite a bit, was the resin smells pretty badly, and it's definitely not healthy long term at least. So I had to find a solution for this, and of course I first tried to solve it the cheap way. So I got this air filter from Elegoo, which is like this big resin 3D printer company that builds some really great 3D printers that are also decently affordable. But honestly, that air filter didn't make much of a difference in terms of the smell. So the next option was to get a more expensive and larger air filter for filtering the air in the whole room instead of just in the 3D printer case. But also that didn't make much of a difference, honestly. So then I started designing and also building a custom case for both the resin 3D printer as well as the wash and cure station to put them both inside, and connecting the case together with a duct fan towards the window so that the whole air basically gets sucked out of the window. It made a little bit of a difference, but the fan was still way too weak apparently to really address the whole smell. And then recently I was getting a much stronger fan to suck out the air of the case. And this stronger fan definitely made a huge difference, but there still is some smell in the room sometimes, which is a big problem since my roommate wants to use that room also for doing exercise, which is practically impossible because of that. So the only two options I see left now are option one, I get an airtight grow tent to put a desk with the 3D printer inside and then basically go inside that tent to do all the resin 3D printing stuff. Or most realistically, option two is I move the 3D printer somewhere else where it doesn't matter that much that there's smell. Most likely to the hackspace nearby me, where they already have a lot of such 3D printers. Speaking of hackspaces nearby, that's also where I made my next learning from this past year. Build on top of existing open source software. For multiple months I was building my own software for controlling LED strips by using the NeoPixel library as well as some web server library. So I could basically control the LED strips with the help of a microcontroller and Wi-Fi. So you can just connect via your phone with it and then have a web interface to control the LEDs. And then when I was at Exine at some point, the hackspace nearby me, and talked with someone about this software I was working on, the person told me for the first time about WLED, an open source library for controlling LED strips. In other words, from a technical perspective, it was pretty much exactly what I was working on. But unlike my code, this one was actually working really well. Not perfect, especially when it comes to the interface design, which honestly is not very great, more like very pragmatic, let's call it like this, and where you have to get used to figuring out how to control things. But still, it was way more advanced than what I was building, and the best part of it, since it's open source software, everyone can copy and edit the software to their liking, as well as contribute to the original software to make it even better. And that's what I also choose to do. Throwing away the code I wrote for months and instead used WLED, with the plan to make the UX and UI design, which I already partially created, and add it into my version of WLED called GlowOS, which of course, like WLED, is also fully open source, and you can find it, like all my projects, in my GitHub repo. And honestly, I was mostly happy when I realized that I could now throw away basically all the code I wrote over the last few months and throw it into the bin. Because it also meant that I was finally able to overcome these issues that have been causing me a lot of headache. Since it turned out developing software and especially debugging it on an ESP32 microcontroller is very painful. And speaking of issues I wasn't able to overcome, this brings me to my next learning. Learn when it's time to stop working on a project. In other words, let's talk about glow stripes. The first LED project that I not only designed for myself, but also planned on selling to other people. But that actually never happened. While I was able to get it working from a software and electronics perspective, I was not able to fix one major issue, and it was stability of the physical structure. So originally I created a design where I wanted to have multiple V-shaped aluminum profiles with LED strips basically stack on top of each other. So you can kind of create like a tower that's mostly freestanding with just one connection at the very bottom to the wall. But I wasn't able to find a solution that's both 3D printable and slim and doesn't require more than one connection to the wall. And basically with the slim 3D printed design that I made, once I was adding more than one aluminum profile on top of each other, it started to bend. So instead I basically published all the files I created so far on my GitHub repo, and with the clear recommendation of not stacking multiple glow stripes on top of each other, and then continued working on more promising projects. But in the end, the idea of glow stripes was reborn and another project. And that brings me to my next learning. Learn from friends and other makers. When I was visiting a friend who I haven't seen in a long time, he was showing me an LED project of him, an LED strip inside an acrylic tube, which made me realize that by using an acrylic tube I could fix my stability issues because of this larger surface area and just the rigidness of acrylic in general. But at the same time it would also diffuse the light very nicely and create this really beautiful look. And this inspired me to work on my 3 main projects this past year. Glow tube, an LED tube for on the wall, controlled by Glow Hub, a controlling unit for controlling multiple LED strips with my WLED based software. Then there's Glow Tower, an LED floor lamp which glows in all directions, 360 degrees, and with the control unit integrated directly into the case. And then there's Glow Light, a desk lamp with the same design as Glow Tower, but much smaller so you can easily put it on your desk. But of course, no project is perfect in the first version, and that brings me to my next learning of this past year. Make your friends and fans your first customers. I made a lot of improvements and changes to Glow Tube and Glow Hub, as well as Glow Tower and Glow Light, replacing the integrated power supply with a simple USB-C adapter for power, making the cases smaller and other things. And I wouldn't have realized the need for those changes so quickly without the support of friends who tested my first LED lamps and who gave me very important feedback, which I highly appreciate, because the earlier you fix things, the easier, faster and cheaper it is. And if you want to be one of the first to try out my updated LED lamps, check out my online shop, glowingkitty-led.com, which is currently only open to friends and fans and therefore password protected. And while I kept improving my LED products and building more and more prototypes based on existing PCBs with microcontrollers, LEDs, microphones and so on, I started to realize that I'm spending way too much time on connecting them with wires, solder and wire connectors. Plus, 2021 was also another year massively impacted by the chip crisis around the world, causing electronic components to be often unavailable, or if they are available, having often super long delivery times and getting more and more expensive, which made buying parts for prototypes and DIY kits a lot more difficult and expensive to do. And this brings me to another big learning of this past year. Want to build hardware? Learn PCB design. Designing custom PCBs has a lot of advantages over just buying existing boards and connecting them with wires and solder. First, you can decide which components you need and which you don't need. So you don't have to spend extra money on an expensive chip, which you don't even need for your project. Second, you can adapt your design in case there are parts that are currently unavailable or ridiculously expensive. Third, your PCB can be a lot more compact. Fourth, they're way cheaper than buying boards from other companies and then connecting those. And 5, you can easily just order them from PCBWay, JLC PCB or other PCB producing companies instead of having to find a good seller that sells a specific board. The only downside that really made me also think twice about learning PCB design was the learning curve. While there seemed to have been a lot of positive change in the last few years when it comes to PCB design software, most noticeably KiCad was improved quite a bit and just recently actually released in version 6.0, which is great. It's like an open source software and it's quite powerful. However, PCB design software in general is not super easy to learn, and once you learn one of those, it doesn't necessarily mean you can use them all, like that you understand how to use them all, since they all work quite a bit differently. However, I'm not that much concerned about this anymore, since I do know quite a few people who know more about PCB design than I do, and who I can ask in case. Plus, there are some really cool Discord communities that are very lovely and supportive. Everything from Adafruit group to WLED group to KiCad of course, and other Discord groups. Plus, finding good documentation for parts that you can put on your PCB design is a lot easier than finding good documentations for existing PCBs that you can buy on Amazon or AliExpress or eBay. And there's another thing that can save time when it comes to designing PCBs for multiple different products. And that brings me to my last big learning of this past year. We use PCB Designs. Often products you design share a lot of things in common, like they have the same key electronics, often even the same layout besides a few detail changes. So why always reinventing the wheel if you can save yourself a lot of time by building on top of existing PCB designs? And I did this in multiple ways. First of all, my very first PCB design is actually based on existing open source PCBs from Adafruit. The Adafruit Feather ESP32 board, another microphone of Adafruit, and it also makes it a lot easier to design especially more complex boards as a beginner, and having it more likely that it even works directly on the first try. And in addition, I realized that Glow Hub, Glow Tower and Glow Light could all use the same PCB design for powering the LEDs and controlling them via WLED. And this is why my first PCB design is called Glow Core and will be used in all of these 3 products, which also saves development time and also reduces the cost of the LED lamps. Well, so much about 2021 and what I learned this past year. But what does it mean for 2022? Let's talk about that. First, I will finish designing and ordering the PCB design for Glow Core, but then I will also design a PCB for Glow Tube for connecting to the Glow Hub. But there are also some other LED products that I have in mind that are very similar to what I already created, but have a very different use case, which I also want to further explore and build. More on that in the coming weeks. The online shop, which is currently only for friends and fans, and therefore password protected, will also be released to the public, and I will start to promote the shop more as well. And when it comes to the software which runs on Glow Core, don't worry, I haven't forgotten about that. I will take the UX design which I previously made for my software, update it and make it work with WLED, and then integrate it into GlowOS, my version of WLED. In addition, I also want to go back to my roots when it comes to LED products, by finishing the design of glow arms, the LED wristband which I started to work on a while ago. But this is a project where I really need to get some more experience when it comes to PCB design, since the way it looks like I really need to do a flexible PCB design here, which also comes with other challenges. But to summarize my main priority of 2022, it's all about going from building LEDs as a hobby to making a living doing what I love doing, building LEDs and selling them. This means I need to find funding for mass producing the LED lamps, decide which LED lamps to produce first, prepare the design for manufacturing, and also be able to make a living doing that. So, as you can see, there are a lot of exciting things to look forward to this coming year. And of course, this only scratches the surface. And I really hope there will also be more events happening and that I will be able to join them as well. Everything from events in the hackspace scene to Burning Man in the US. So yeah, let's see what the coming year brings us, and let's hope it's gonna be better than 2020 and 2021. Yeah. See you in the next video, and up to that point, have a good time and stay healthy. Bye.